In this video, we're going to look at limiting reagents. So in the past, if there have been multiple starting materials, multiple reactants, typically we've just said, oh, we have a certain amount of one thing and excess of something else. When you're given actual amounts, moles, grams, whatever, of multiple starting materials, that's when you have to treat it as a limiting reactant scenario. Maybe you have a perfect ratio where both of them run out at the same time, but more often than not, there's going to be one material and the other material that react, and the amounts of them decrease, and then you run out of one while still having some of the other left over. So let's consider this reaction. 2 hydrogens plus oxygen gives you 2 waters. If you mix 4 hydrogen molecules and 3 oxygen molecules together, how many H2O can you form, assuming that you get a 100% yield? Well, I know that every 2 hydrogens reacts with 1 O2. So if I have this hydrogen and this hydrogen molecule, they'll react with this oxygen, and I'm going to get H2O. I'll get another H2O. And I've used 4 hydrogens, just like I've used 4 hydrogens. I've used 2 oxygens and 2 oxygens. I can keep going. These 2 hydrogens will react with this oxygen, and I'll make 2 more H2Os, but I have a remaining O2. There is no hydrogen left to react with this oxygen, and so it's just here as O2. So I can only end up making 4 water molecules, and then I have a little bit, well, 1 oxygen molecule left over. So that's the principle at play here with the limiting reaction problem. And if I were to do a calculation and I said, okay, we have 3 oxygen molecules, how many water could we make? Well, I would get 6 waters from my calculation, which if you only have 4 hydrogen, it's not going to happen. That being said, if I said, okay, we've got 4 hydrogens, how much water can we make? 4 water, apparently that's possible because we could get 4 waters even though we had an extra oxygen left over. That's not a problem. So academically, how do we calculate the actual amount of product to be expected when we're given 2 amounts of reactants? Well, let's consider this reaction. We have 4.04 grams of hydrogen and 16.0 grams of oxygen. What mass of water can be formed? Well, there are a couple different schools of thought on how you could solve this. I'm going to try a way that is going to be familiar to you based on what we've done before. I'm going to say that we have 4.04 grams of hydrogen and we have 16.0 grams of oxygen. And I'm just going to go to moles, and I'm going to go to moles, and then I'm going to go over to moles, and I'm going to go over to moles, I'm going to go to grams. So what I've done here is I've just mapped out 2 parallel mass-mass problems. In this first one, I'm saying we have 4.04 grams of hydrogen. How many moles of hydrogen are there? How many moles of water could you get, assuming that the hydrogen is what runs out first and you have enough oxygen to react with it? And how many grams of water is that? Then simultaneously over here, I've got, okay, we have 16.02 grams of oxygen. How many moles is that? How many moles of water could we make from the oxygen that we have, assuming the hydrogen is in excess, we have plenty of it, and it's the oxygen that runs out first? And then how many grams of water is that? So both of these calculations are assuming the other one runs out first. So let's see. Let me do the hydrogen calculation first, and I'm going to do that in red, just so I have separation of 2 different problems, or 2 different calculations. 4.04 grams of H2 times 1 mole over 2.02 grams of H2 times 2 moles H2O over 2 moles H2 times 18.02 grams of H2O over 1 mole H2O. So I've done that. And even before I calculate, I'm just going to set up the other calculation for oxygen. So we have 16.0 grams of O2 times 1 mole over 32.00 grams of O2 times 2 moles of H2O for every 1 mole of O2 times 18.02 grams of H2O for every 1 mole of H2O. And that's going to give me a value as well. So approximately 16 times 1 over 32 is going to give us a half, 1 over 1, 18.02. So we're going to get 9.01 grams of water that could be produced based on the amount of oxygen we have. Again, that's really important. If the oxygen runs out first and we have excess hydrogen, this is as much water as we can get. But let me also do the same calculation based on the hydrogen. 4.04 grams is 2 moles, 2 over 2, we still have 2. This is actually going to be 18.02 times 2 is 36.04 grams of H2O that can be produced if we assume that the oxygen runs out first and that we have excess hydrogen. So how much actually is produced? Well, what is the actual reagent that runs out first? Apparently, it's the oxygen that runs out first. Because we've got enough hydrogen to make a lot more water, we have enough oxygen to make only a little bit of water. So it's the oxygen that runs out first. And our answer is our 9.01 grams of oxygen. So that is how you would approach a limiting reagent problem. If you really wanted to, you could throw in a % yield on this too. But for now, we'll keep it at just this. Hope you've enjoyed. Hope this is useful. Let me know your feedback. Thank you.